As I said, good to see you here Friday afternoon, 3 p.m., last day of the conference. Hope you're enjoying yourself so far. And I'm pleased to see you here. In the next hour, I'm going to talk you through about using WebAssembly to run, extend, and secure your .NET application. First, it's always polite to introduce yourself, right? So who am I? I'm Niels Tanis, and I work as a researcher for Veracode. And I have a background in .NET development and security consulting, pen testing. So that means breaking into systems, doing fun stuff, and also building software, which is the thing I like the most. And in my current job at Veracode, I mostly focus on everything we do with .NET and static analysis, right? So finding flaws and helping our customers to fix things. And I'm also enjoying a lot of Rust lately, which, if you want to learn a cool language, then I would suggest you look into that. We're going to see some Rust in this talk as well. We're going to talk about WebAssembly, and Rust and WebAssembly are closely tied. That's all what I'm going to say about Veracode and about my employer. I'm also Microsoft MVP, and I do a lot of public speaking around security, .NET, and in general. But today's topic is going to be WebAssembly. Who in this room was in the first session of the day with Steve Sanderson? Everybody, cool. He put on the agenda, I'm going to talk about preview 2 of something I'm going to touch as well. So like, oh no, please, don't show too much, because then my demos are going to be like, oh, I need to revamp. But it was fine. I've got the whole story around like what he showed today, and that's the end thing. And in between, we're going to talk a lot about technology, what you can do with it, how secure it is, right? Because that's my area of expertise. So there's a lot to cover. So don't worry about that. WebAssembly in general. As Steve also pointed out in his timeline, 2017 we had a release done to all major browsers, and it was like the minimal viable product, as they call it, MVP, which allows you to have a binary format that's portable and that can be run inside of the browser. It had some other aspects which we're going to touch, but it's like in browser performing, so using it for rendering stuff quickly, doing stuff with video, and so on. That was one of the goals. What happened after that, right? That was the first thing. So people who are familiar with AutoCAD, that's the drawing thing that an engineer would use if he maybe draws a specific, let's say, building or equipment or whatsoever. They took their C code base and took a tool they called them Scripting to compile their tool into WebAssembly. At least it's probably a lot more complicated, but they were able to take big parts of the code base and get this thing running, right? That's pretty cool if you can do it, right? Getting stuff easily used. I think Adobe has done stuff as well with their tooling. So that gave a lot of potential. That was the first thing that happened when WebAssembly was introduced. What else happened? Something that I think everybody uses nowadays is the streaming services, right? Disney+, Amazon Prime. What they do is they use WebAssembly as an SDK for their SDKs, because it can be used as a compilation target. You will compile to WebAssembly, which you're going to see later on, but it will literally run everywhere. So for example, Amazon can compile easily and make sure that they can deploy on 8,000 different devices with their version of their software, because everybody wants to see that new series once it gets released, right, and binge watch it. And the same counts for Disney+, and it's all the stuff you see in the apps that you use on your mobile, but also inside the browser. They're all like sharing stuff, and WebAssembly is enabling that. So those were the first bits and pieces that we saw with WebAssembly. Pretty cool. And now we're going to move on to what's next, like what will be happening next. As I said, we have an agenda for today. I believe we're going to touch on WebAssembly and why it's secure, because I think there's a lot of goodness in how it works internally. Then we're going to run .NET on WebAssembly, which you probably can figure out what that will be. And then we're going to take a way of approaching how we can extend an app with WebAssembly, a .NET app in this case, and security with some different aspects, what you can do with it. At the end is conclusion QA. So this is in the stretch that the agenda. The design, if you look at it, if you go up to the website, you will find the following bullet points being mentioned. It needs to be fast, efficient, and portable when it started out. And because you execute it inside a browser, let's say, for example, you know those video apps that need to perform, right? It needs to be readable and debuggable. So WebAssembly itself is a bytecode format, but there's also a textual representation. And if you use Edge development tools, you can go to the tabs underneath with the web developer, and you will find that text representation as well. You can read it and see it, right? It needs to be secure. And of course, in the browser, it's relatively easy because you have same origin policy. something gets rendered from one origin, like it's almost the same as a website. If it needs to access something inside the browser, it will use JavaScript for it, right? So it has those limitations as well. And the last bit is something that's important for the web. You don't want it to break the web. When we had the browser wars in the beginning, standards, right? It's maybe a big word, but creating browsers and having stuff available. If one browser failed at doing certain thing, then everybody would start using another one, right? We had like Chrome and Firefox switching, and at the beginning Netscape, maybe even in the early days. And you don't want to break it, but you don't want to lose users in your code base. That's not what you want. And backwards compatibility, which of course for security is a bit of a tough job. Backwards compatibility will always cause issues, but for web it just works like that. As I said, WebAssembly is a binary instruction format, and we're all probably familiar with .NET, right? It's almost similar to a stack-based machine that we use for .NET to run MSIL on. And it's designed as a compilation target. So you can, of course, write WebAssembly with that text representation, but you don't want that. You probably take a thing that you write in either .NET or, let's say, Go, Rust, Python, and compile it to WebAssembly, or allow it to run on WebAssembly and go from that angle. They also have the goal of a rich security model, and this is where it gets interesting. So they want to protect users from broken or malicious modules, right? Because if we write software, a lot of stuff that we use is written by others, which of course is good, but there is a risk with that. And we also want to have useful primitives to make sure that users create like safe applications. And I think the reason for that is you want the APIs that you use to be as descriptive as possible. And I think once we moved to .NET Core and we had some of the APIs getting explicit, once you do something stuff that's really bad, let's say like suppressing certificates, dangerous something handler, that's how it's called, right? You will do some things that are not good. And I think the API should have good defaults, and if a person needs to do something else, you need to explicitly do that. And I think that's the goal, and that's a good goal. But looking at that in general and talking through all those dots, what really is one of the key blocks that makes WebAssembly secure? That's the way how it deals with memory. Because on basis, a WebAssembly module has its own memory. Each module that you load, and we will see, let's say a single file will have its own memory, which is a mutable array of bytes. In this case, you see over here, this is hello being represented in an array. These blue drawings are the ones that I've taken from Lynn Clark's code cartoons. Go search for her. She writes up a lot of articles around even WebAssembly and the stuff that we're going to touch in a bit. You're going to see more of these drawings. But they always are nice in the story to tell. She's also part of the Bytecode Alliance, and she helps out telling the story, so that's cool. But this makes WebAssembly secure because the module only is allowed to access its own memory, and it cannot, without any help, it cannot access other memory, right? That's the thing. Another thing on top of that, so a module can only access its own memory. Another thing on top of that, a module can still become malicious or have a problem and mingle with its own memory, meaning that if there's a problem in it, I can still have a procedure that will throw stuff around that will make it crash or maybe do some other stuff. We need to have an additional layer of defense. And there is something called control flow integrity within WebAssembly. And when I started out creating this slide, I thought, what will be a good way to explain what control flow integrity is? So everybody does C#, so they can probably understand what we see here. It's just a code base where we have a certain path that we can walk through, right? Based on how it executes. There are two different routes within this code. So we will read a number from the console, we will write it out, then we will have that condition saying like, hey, if number is greater than 5, we're going to say it's larger than 5. Otherwise, we're going to go to the second compound you see over there, and at the end, we're done. So if you look at it, it can be drawn inside a map. And hypothetically speaking, it could look something like this. So we have one piece of our code, which is the first block that will always be executed. Then we get into the point where we take a decision, and we're going to go either the far arrow or the nearest arrow on that, based on if the number is larger than or not. And then at the end, we're done. So what it does, control flow integrity, at compile time will check possible paths, and it will keep a map of it. And during runtime, the WebAssembly runtime will check it. And if it sees something that doesn't match one of the paths, it will panic and it will stop executing, right? So if there is a module with ended up some malicious stuff inside or some bug that was found, and something happens that's not supposed to happen, then the WebAssembly runtime will panic. And we will see a panic later on as well in one of the demos. So WebAssembly modules, own memory, combined with control flow integrity, which is a nice long sentence, will make it more secure. It's even as secure that if you're using Firefox as your main browser, and I'm doing it myself right now, there's a real cool thing inside of it that leverages WebAssembly and also leverages because the language and the constructs I just talked about. So there is a project called RLBox, which was created by a university combined with the people from Firefox. And what they've done is, if we render browsers, it's always about rich content and about plugins that render fonts, videos, and stuff that happens inside the browser. In the early days, we had a single process browser that will render stuff, and once one of the plugins failed or there was a vulnerability found, let's say you could point out to a malicious font and it will execute code. Those things did happen. You will be compromised. So what they did with RLBox is they said, okay, let's take plugins that are written in C and compile them to WASM. And then we at least have those guarantees I just mentioned to you. That will make it safer. That will make sure that the likelihood of something occurring less, because you're never going to eliminate it, right? But it will be better. Then they thought, but we don't want to ship a code base with both these different types of technologies in it, or something that is a binary and then a WASM module that had been put inside of it. So they decided to do the opposite route, again, by taking the WebAssembly and converting it back to C. So they're leveraging the fact that WebAssembly has all those security things I just talked about, and then they still converge it back into their C code base and allows them to compile a Firefox and use it. So that's pretty cool, because it is that safe, between quotes, right? It mitigates a lot of risks, and you're already using it inside Firefox today. Cool project. So if we're then going to look into running .NET on WebAssembly, hypothetically speaking, a code base could look something like this, right? We have user code, IL, or something you've written yourself. We have the base class library, BCL, standard library, that gives us all system file I/O operations we're going to see in a bit. Then we have the execution engine, or sometimes called VES, which will run on a host, right? So the VES is our CLR, and our thing that bootstraps the process and starts it out. How can we run this on WebAssembly? So what happens is that the execution engine, VES, can run on WebAssembly if you compile it to WebAssembly, so it's a C code base. And that's exactly what's been done, right, for Blazor. Then you can run it inside the host as a browser in this case, right? So the execution engine is running on WebAssembly.NET, and it will run the .NET DLLs, like no modifications whatsoever, inside your browser. And that's exactly how our Blazor works, right? If you have Blazor WebAssembly. And I'm not going to bother you with the demo and show you how it looks, but if you create a new project and the first hit of the project itself and it starts, you will see it will download all the DLLs it needs. And then at the end, we have .NET WASM being started, and that's the CLR, and then the process gets started. And yes, there is ahead of time, there's a lot of stuff happening. You can optimize things, which is good, right? And there always will be a piece of .NET executing. That's a whole different story. There's a nice video done by Daniel Roth where he explains like when you want to do IoT or not. But in general, let's assume we have the CLR, that is the WASM file that will execute .NET DLLs. And if you want to do something that's not inside the browser, something else, or interact with the browser, of course you need the JavaScript bridge, right? Those are the JS files on the right-hand side. So Blazor WebAssembly, allowing us to run .NET on WebAssembly inside the browser. But what if we want to run it outside the browser? We want to eliminate the browser, right? What else do we need? So we still can use the CLR, but then we need to have something else that supports the WebAssembly-based CLR to execute. And this is something where WASI comes in. And WASI stands for WebAssembly System Interface and was introduced in 2019 by the Bytecode Alliance. They also started out a runtime that is a reference implementation to them. It's called WASM time. We're going to use it today. That's the runtime that does it. And It's a POSIX-inspired, engine-independent, non-web system-oriented API for WebAssembly. Nice sentence, right? But it will allow you to do basic stuff on a system, and there are file descriptors. That's like the generic approach. It has been shaped a bit differently, but that was the default how they started out. What else does it give us? The goal was to have a strong sandbox with capability-based security, right? So in order to do certain operations, by default, the WebAssembly runtime won't allow you to do that. And right now, there's a lot of things you can do with file system. We're going to see it in a bit. And with that preview 2 that was mentioned by Steve this morning, there's going to be a lot more like sockets and also a slightly bit different model on how you program with it. Today is going to be preview 1, and it will show you how the technology internally can work. And I will assure you that the demos will have a lot of code, but that's just a necessity. But with preview 2, we're going to do that .NET with that was showed, and it's going to be the next thing, right? And I'm in the last thought I say, does anyone recall Net Standard, right? Net Standard was used to converge the .NET frameworks into a single spot. And you can see WASI as a standardized BCL, but then with security on top of it, with access security on top of it. Pretty cool. So when I read this, I thought like, oh, this is exciting because sandboxing, like limiting stuff and having no access to things by default, that's pretty powerful. And then in 2019, when WASI was published, Solomon Hykes, one of the guy behind Docker, published this tweet saying like, hey, if it would have existed in 2008, we would not have to, there was no need to create Docker. And this probably stirred up a lot of like, maybe not like people who were complaining, because the day after he tweeted this, saying like, okay, will it replace? No. But I can imagine it will run good next to each other, like side by side. Right? So it's not different, but it will be something that can like coexist. And that's exactly what we saw. And this was 2022, a year ago, when Docker was introduced to also like be able to run WASM-based workloads, right? So we can run containers. I'm not so sure if you're able to see it on the right slide, but there is the run C that will have the container process. On the right-hand side, you see there's WASM Edge, similar as WASM Time. That's a WASI-compliant runtime that will allow you to run WebAssembly modules in that same context, right? So this is pretty cool. So workloads, much smaller into, let's say, a Docker piece. This is where it gets cool. So looking at the picture we saw before, we have the execution engine that will execute our code, but we need to have a host. And in our case, if we want to take it outside the browser, it will be WASI. And in my case, it will be WASI together with WASM Time. Because I think it was build of last year, Steve shared this experimental SDK, which allows you to create an app, which will then be packaged into a WebAssembly module, a WASM file, and that WASM file will be containing it all, right? So that will have a .NET CLR in it, that's the WASM, that will start it out, and there's a bunch of DLLs, and it will be bundled. This thing is something that, what will be the next step, and if you go to, I have another slide which comes after this one, I guess, or not, let me see. Yeah, so with .NET 8 Preview 4, this has become a template that you can use out of the box. But right now, for my demos, I'm going to rely on the package that I will get, right? So that's the first SDK package that we're going to use. So let's see if I can get out of my presentation. I move to code. Is this big enough for the people in the back, or do I need to increase it a bit? Can always do that. And I heard that the white team is much better than black one for the contrast, so we should be fine, right? So basic demo, you've probably seen this. So as I said, I'm not relying on the new preview. I'm just using the SDK for that matter. So that's just reviewing, that's the package that I'm referring to is the WASI SDK, this version. And what we're doing here is we're going to write the OS architecture of where this process runs in, right? This is the default demo you've probably seen already. So let's go to console app. Let's do a .NET build. And if we then look into the debug output, what's happening? We will see we have a WASM file being created. Let me do this, see if you can see it up there. We also see that it's about 8.5 megabytes in total. That's the WASM file. And we also see a .NET DLL itself. So if I now just take the default executable and start it, you will see it will say, hey, hello from ARM64, which is my Mac that it runs on right now. If I do the .NET run in the root, it will take WASM time. And let me just do it right away. And let's say WASM time, and then move to console.wasi. You will see it will show us. It will run inside of a WASM-based architecture instead of ARM, right? So that's the key difference. It's the same DLL, and we get the output done. So, okay, Niels, that doesn't look like any fun stuff. Let's do something else. Let's say, for that matter, right now, I want to open up a file and read all the contents of it, right? So let's say system IO file, read all text. And let's say I want to do it on my system, and I want to read the etc hosts file on my Mac, and then say write out those things to the console. So it should be all text, yes. So if I do, again, if I now take the binary, you will see it will be saying, okay, hello, and it will open up the file. If I now do the .NET run, which will underneath do the WASM time, you will see it will miserably fail. And why is that? Because, as I said when I started out talking about WASI, by default it has no access. In order to access, we need to instruct it to have access. So we need to say, WASM time, I'm going to give you a pre-opened dir, and I'm going to say you're going to be able to access /etc. And then I'm going to say, okay, let's take bin debug console app WASI WASM. And what we see there is that because I granted it access explicitly by saying pre-open this dir, it's allowed to access that folder, right? So this is one of the capabilities that was in preview 1 that everybody uses and everybody shows. We're going to see one later on in the next demo as well. But with preview 2, it will be much more granular. We will have a lot more to choose from and to combine. Then it gets cool. But you can already see its potential, right? I'm already happy that if you have a module and you're pulling something in, and you can also limit by programming against it, saying you can only access this, that's powerful, aside from the fact that you still want to have it locked down, maybe running on an environment that has least privilege, that won't access the internet if it's not needed, right? Those are additional layers of defense. Keep that in mind. It's not the Holy Grail, but it's a nice addition to what we're doing already. So, as I said, experimental workload, you can just do it, and then you do a .NET New WASI console. You'll have the same. The only thing right now it doesn't do by default is bundling up the files that I did. You will see there is a file, and then the contents of the WASM file are shown there, and you can still bundle it up. There are some options. There's a nice video. That's where Steve explains this. So, what else is fun, right? Because we're able to run .NET on WebAssembly by Blazor. That's what we do inside the browser. We can take it outside of the browser by using WASM time based on WASI. We can also extend .NET with WASM. And Peter Yoon, who also does a lot of work on WASM time in general, has created a package that allows you to run WASM time inside of .NET applications. And it's just a NuGet package that you can put in. And what about if we then take a Rust-based module and run it inside our .NET application, and then work from that, right? So that's the next thing we're going to look into. So let me switch to the extend folder, so all demos are on GitHub. Honestly, I did put up the slides, yet I need to commit the code. I had some issues this morning, so it needs to wait for that, but I'm hoping at the end of the day, stuff will be on my GitHub repo. But we have a Rust module. Now let's look into that one right now. We're going to see some Rust. You're going to see there's a lot of familiar things if you're already a .NET developer. So this is just an ordinary, almost like console app within Rust. It has a main, recognize it. There's, oh, sorry. And I was already relying on you complaining we're not seeing anything, Niels. This is the one. So I have, this is the Rust project. This is the one that we're going to compile to a module and then use inside our .NET application. And as I said, probably looks familiar. There's a console app, it has a main. It will get the arguments from the command line, and then it will pass it to that process method that's up. And we're going to do some copying of files again, because that's the thing that we can control, right? So it will just copy it, it will try to do it, and if it fails, then it will give an error. So this is something that we can compile to WebAssembly. And if we look at, hold on a second, should be there. If I go to extend my Rust module, you will see there's a target folder. And if we go inside the target folder, there's debug output. And then we will see this name is slightly bit different, but this is a WASM module that was compiled with the newer version. We see over here there's the WASM module itself. And you can just take that one. And that's what I'm doing with a console app that consumes it. So I just copy that file to that part. And now if we look into this one, let's open it up in our VS Code. Close this one out. We see some stuff happening. And there's a lot of code, as I said before, because this will show you what the technology can do for us. And we need to have something around it, which we're going to move into later on. So as I said, this is just taking WebAssembly WASM time as a package reference. And right now it's already at version 13, but they're keeping it in sync with the runtime itself. It bumped up a lot of versions over the last couple of months. But you can just include it. It will be there to use. And then we can instantiate it from our console app. And there's some funky stuff happening with config, right? We need to have an engine that runs it. We need to link some stuff. We need to make sure that WASI is available. And then we're going to say, OK, load this module, which is our WASM file. And there's a WASM folder that has a copy script that takes it from the other project if you want to run it. Load it, instantiate, and run it, right? So if we do this, .NET build to make sure my fingers did not smash up anything. And now let's say .NET run. We will see it says usage calls from, and I'm from to. That's the file. That's the thing that comes from the WebAssembly module that I linked in. And let me quickly show you something. Because I said to my WebAssembly runtime, I want you to just connect the standard out, standard error to the apps itself. And I'm also passing on the arguments of my console app to the WebAssembly module. So it needs to say, I want to copy from A to B. So you already probably guessed what I'm going to do. Let's say .NET run. Let's say I want to take etc host again, that file, and copy it to my local folder and say it needs to be copied to host. Luckily, the Rust module is a lot more polite with its error and says to us, hey, you're opening a file which has not been part of our pre-opened set of directories that I'm allowed to access. So what we can do is we can pass it on, and we can pre-open it, right? For that same reason that we saw before. So I need to give access to etc again, and these arguments are just being passed on. Not by this way. Hold on, I'm mixing up. So this is not working. We need to instruct our runtime that we have inside our code to have the directory pre-opened. This is the configuration. So I can say over here with pre-open directory, and I'm going to say, OK, you're allowed to open etc with that child process, and by default, it has no access to the current directory as well. So we need to make sure that that one is included as well. So this should be fine. Why do I still get the red squigglies? OK. Guess path. It needs to have 2 arguments. So we're just going to map the same. Hold on. So, and this is also just the same. So you can even map it to something else and virtualize stuff, which is a nice option as well. So cool. Let's now do it again. Let's make sure that we do a .NET build in order to have my fat fingers not failing. And now let's do the .NET run again with copy. And hopefully, we will see that there is a host file being copied to this folder. And that's exactly the case, right? We should see it appear here as well. Yeah, there it is. So by instructing our WASM time that we run inside our .NET application, like, hey, this module can access this file, and you can even reroute it, right, as you saw with the config, we have a lot of control of what our module is allowed to do. That's pretty cool. Still, an awful lot of code, right? I get that. what else can we do? And I said there's something else. So within WebAssembly, there's a concept called fuel. And if an operation executes, it will take a certain amount of fuel to complete. So let's say you have a module that you load from some external source, and you know for a given fact that it should take X amount of fuel to complete, then and then you take a safeguard and then say like, okay, once it exceeds this value, there's probably something wrong. There's additional stuff happening that I don't expect. So you can configure that one as well. And that's done by enabling fuel consumption on the engine config, and I need to fill it up with fuel. So I'm going to do that, 30,000. I'm not sure if that's enough. Let's say 50,000. And then at the end, I want you to see the amount of fuel it consumed. Right? So let's make sure that we remove the hosts again, that we can do it, and then .NET Build to make sure I haven't made any mistakes. And if I now do the same copy, we will see it takes us about 35,000 and something fuel to complete. Right? Let's say I put it into a lower figure and say, hey, I know it should not take that long. Let's say I want to complete it within 20,000, right? That's not sufficient. So .NET Build, make sure the host file is gone, and say .NET Run, same, and it will fail. And this is one of those traps that I talked to you about, right? This is exactly what you see. So because it was doing an operation and it ran out of fuel, it stranded and it stopped executing. So this can be a safeguard for security. And yes, it's rough, there's a lot of code, but trust me, there's going to be a lot more goodness once this moves on to Preview 2. There is also a way to limit even memory in the same way. You want the module not to consume more memory than X, you can influence this as well. Pretty cool. So getting to the point where we have run .NET on WebAssembly and we've extended it, what else is nice and what else can we do with it? It's something called trusted computing, and this is an XKCD that I took from a website, which you can see explains what the modern tech stack looks like and what happens if you look at it from a security perspective. So at the top, you have compromised by a customer, right? And then the former employer who's gone rogue and tried to decide to do some bad stuff. And once this goes down, you get up to the hardware layers that might be compromised by a foreign government. And then, of course, there's that hardware vulnerability that gets found in the next 5 years or something, right? This can be a risk model if you look at it from a cloud compute perspective. If you run on either, let's say, AWS or Amazon or Google Cloud, whatever, then technically speaking, this is your risk model. And depending on that, of course, you can decide to be paranoid and to do something else. So some people from Red Hat and combined with some others started out a project called NARCS. And it's all about confidential computing. And what they have done is they have taken the ability to run a WebAssembly module in an even more secured way. And NARCS is an open source project. It's still is available. Has the following threat model where they want to eliminate stuff. They say like, hey, we don't trust the host that it runs on. We don't trust the host owner, so we don't trust either Amazon or Microsoft to run our workload. We want to make sure that the hardware is cryptographically verified, which means that by looking at certain chipsets, and we're going to talk about the T that executes this, there is a hardware signing key inside that chip that can be verified, that you know for sure, like, hey, this is a chip that came from Intel, or this is a chip that came from AMD. And that's some kind of trust. You still put trust in that vendor, right? I get that. Might be somewhere in between. But you can verify it. And also, NARCS itself is a runtime you can download, and it's publicly available, which can be looked at by everybody. There's no secret sauce. There's nothing happening that's that you should not be aware of, right? I'm not saying it should be easy to look into, but it is a runtime that's available. So what they've done is they take the trusted execution environment, or T, which is directly on your processor, and that's based on those 3 different types of AMD, Intel, and IBM's implementations. And it will do also an attestation of the hardware once the NX runtime start out. This is pretty cool. So it has some heuristics on when it starts out on a certain chip that it knows that it needs to complete within X amount of time to make sure that it's really running on that chip. There's a lot of cool stuff happening. And what they rely on to run is WASI, WebAssembly. And when I started out like including this project into my demo slides, I thought like, hey, I can show this is cool. But technically, if you run it on your own machine, it's just a WASM time runtime that runs. It's not that real thing if you need that, if you don't have access to that hardware. So it's not adding up. But this is pretty cool because you can, by that, eliminate all those layers in between. And because you are in that CPU level, it even encrypts the process and the memory it uses. So the host doesn't have access to what's happening. It gets computed and it will return the results. So if you do stuff that's really confidential, and you don't want anybody, even a cloud vendor, to look at it, this is a model that can work. Unfortunately, there was a company called Proofian who was part of NX, or at least like that was the commercial branch of NX. They stopped this beginning of this year. NX is still around and is part of the Confidential Computing Consortium, so it's still there. I haven't seen a lot of movement on the project, but I'm assuming there will be, because some other big vendor also gave more attention to trusted computing in general, which of course is what we've seen built when Marcus Sinovich showed all the Azure innovations, right? He had a lot of stuff on trusted computing and confidential computing as well. And we also saw something called Project Hyperlight. I'm not sure if you have seen this video, where he takes a different way of sandboxing. This is almost similar to the drawing we saw from Docker with the 3 pillars, right? We have virtual machines, the bigger ones. We have containers, but we also can run micro VMs, which are just technically WebAssembly modules, right? Quite small, really quick. If you see his demo, you will see it scales pretty well. Has got a lot of responses. It's like memory consuming. His footprint is pretty low, so it's good to run that type of thing. And he also showed some code where he takes C# code and wants to run it inside an isolator. And when I saw the demo happening, I thought like, hey, that's the .NET isolator that Steve showed a couple of months ago, where he takes .NET and runs WebAssembly inside of .NET, or .NET inside of WebAssembly. And he shows the picture where he has like multiple things inside. In my demos, I also have .NET on WebAssembly on .NET combined, because why? You can do it. Is it efficient? No, it's fun. But he showed that it can work like that. And I was intrigued with the code flow, because it was just like an invocation of an action, and that will move it into that other context, and it will make it separate. And that's also what Marcus Sinovich showed. And then, if you're into WebAssembly in general, there's cloud-native WASM days, and there was also WASMCon held in Redmond a month or so ago, I believe. And there was Dan from Project Hyperlight talking about how they use the hypervisor to secure that workload, right? So that's that confidential computing I just mentioned. Pretty cool. It's a nice talk where he also shows that it's all about how secure the runtime is, and we're going to touch that in a bit as well. So, but it's pretty cool that it gets invested, and there's aside from NX, you also see Microsoft doing the same with Project Hyperlight, and leveraging hypervisors to have that additional layer of defense, right? That's what they're saying, and also high performance, so that's pretty cool. So getting to the point where we've seen .NET WASI Preview 1, and are you going to run it like this? No, there's too much code. It's not usable. So we need something else, and what will be the next step for WebAssembly to take in order to become successful? And I need to go the other way. Hold on. So, and there's another Link Clark drawing. So, if we look at our code base in general, and I think this is maybe tied to every technology stack, but 20% is only our own code, 80% is somebody else's code that we use. A lot of modules, right? And if you look at it from .NET perspective, we grab a package. As I grab, let's say, for example, WASM time, there's probably some dependencies that you get for that with that combined, right? So there's always a transitive tree. And with .NET, the one that starts out the process, right? Those are like that process has access rights on the system and can access things. All the other modules can do the same. It will just pass on the things down, right? So hey, The code starts, hey, you want to have access to that, it will just work, right? That's how it goes with .NET, even with the transitive dependency that's somewhere underneath. What if one of the modules becomes malicious? They put on a mask, right? That's what they do. And they do something else that's not expected. In this case, maybe let's take a peek into the file system. That can happen if you update. Because are you really aware of all the modules that are like loaded and that are part of your dependency graph, right? Supply chain stuff, I talked about that yesterday. So, or what about if a module has a vulnerability that can be controlled by somebody who's like an outsider or an attacker, right? If that's a thing, then this might be an issue. How can we solve this? How can we make this more secure? We can decide to do process isolation, right? So having two processes, both have, if this is like two WebAssembly processes, the memory of both of those sites are isolated. But if they want to communicate with each other, we need to have some way of communicating. If you use your browser right now, you have multiple processes. There is a IPC happening as well. If a tab or like something starts in one process and wants to do something on your system, it will do a pipe call to another process that's in charge of that in order to sandbox your browser stuff. So for modules, you want to do the same. But this is really, really bloated. And this is really big, and process has got a lot of overload. So then, what about if we can create something smaller? And on the top, you see like a small asterisk saying like, this is not drawn in scale. I like this one. But let's say we have two modules that want to communicate. There's a lot of overhead, if you would exaggerate. What about if we can create something like a nano-process, like a smaller bit on pieces? And that's something that they introduced as a WebAssembly nano-process. I think it was in 2019, also when Bytecode Alliance started to talk about this. And what we are able to do with that is that we can say, okay, we can do a sandbox. You can say to this module, you're only allowed to use getRandom. It can be handed over from the main module or the one that's in charge, in this case, the guy with a hat. And we still have the benefits of our module only accessing its own memory. And if it wants to access other people's memory or other data that's somewhere else placed, then it needs to have help, right? So somebody needs to be in charge of that memory. And what they do is like, hey, copy, and interface types are needed, right? This is where the with stuff comes in that Steve mentioned. So you want to be able to copy stuff and exchange it between modules and reuse it. And what we also need is our WASI APIs with a fine-grained permission model that we can influence. Then we can say, hey, you can do this, but you're not allowed to read or connect to this server on this TCP port. You're only allowed to communicate to this server, or you only are allowed to do it on this port, right? There is a lot of granular stuff that we can do. That's pretty cool if you have that type of control. And the missing link would then be being able to have a main process that will decide what the modules underneath there is allowed to do, and nothing more, nothing less. And that's exactly what the component model facilitates us, right? So nano-process is the concept, and the implementation is component model. And this is a presentation done by Luke Wagner, who used to work for Mozilla Firefox. A lot of those people moved to Fastly and are still working on WASI. They're doing stuff for Fastly's cloud workload, I believe. And this is exactly what you can achieve with the component model. Having stuff, interface types defined, right? As Steve showed this morning, I have a component that needs this to communicate with the outside world, or this component needs to have file access to that location, needs to store files temporarily someplace. The nice thing about the preview 2, as what I've seen right now, and as Steve said, it's close. It's hopefully there in the next 6 months. This week, another WASM runtime, WASM Edge said that they're committed to also support that preview 2 bits. So that's cool. But you're able to, with those with files and with those with definitions, you're able to compose your app. And there's no need to do all the bootstrapping I did with .NET, right? Because as Steve showed, you have a host app. That was his console app this morning, and he had like renderers, which are different modules. In the same way I have my Rust module execute inside of .NET. Only the main thing was a .NET application or a console WebAssembly application written in Rust itself, right? And based on that, it can take the with files and compile or like generate where stuff gets from. And you can even limit, say, this module can access these files, or this module will only get a virtual file system to access. That's something that the main module will define and how you encapsulate it. There's a really nice demo where there is a component designer that was created also by Peter Yoon. He shows that, and he can just easily map up. And then you can do that whole limitation in code, declaratively, right? And that's pretty cool. And when I saw that for the first time, I thought like, hey, I've seen this before. I've seen it when I started out my .NET career in .NET 1. So who has developed with .NET probably is aware of something called code access security, right? Code access security was a model that allows you to declaratively also define access stuff on modules and saying this module, if loaded from, let's say, my local file system, can only access this thing or is limited. The biggest example we all probably run into is the medium trust at some point with ASP.NET and hosting. But that's a model where you can declaratively define like what stuff is allowed to do. And that's exactly what you're going to get with the component model and with files. And the other thing is like, hey, components, DCOM is more about distribution, and Luke Wagner in his talk also mentioned that it's not about that in general, but it is that component model, and it's the whole composite things. And I'm eagerly waiting for that preview 2 to drop, so then I can work on those demos and make it a lot more nicer to work with. Because if you can generate the tool that does the plumbing, like the code that does the plumbing underneath, and you can program like against it and give all those access rights, and then sockets should be included. There's a lot more. It can be quite powerful. And then at the last bit, I would still say, getting back to all of this, I was at Black Hat DevCon last year, which is like one of the biggest hacker security conferences held in Vegas, and I was looking into like what are the topics on WebAssembly that they are talking about. What are the things in WebAssembly that we need to worry about? And most of it focused all on fuzzing the runtime itself, which is a good thing, right? Because that will allow you to fix stuff. But I'm not saying that's the only thing we need, but it's a good step forward, right? And you can just see based on stuff how things are being fixed and so on. Bytecode Alliance has a really nice blog post done in 2022 where they talk about how they deal with that from WASM time perspective. So what they do is the WASM time runtime itself is written in Rust, which has all the language security features it has with the ownership model and how it works internally. They do continuous fuzzing, a form of verification of every runtime. So if stuff happens, they will make sure that they go that full stretch and fix it. And that fixes it. And the presentation I showed before from Dan from Project Hyperlight shows one of the bugs that was eventually found by fuzzing. So they show that they have a process in place to fix stuff. And I think that's the key. And that makes it more secure, so that should give us trust. So we can build on top of a runtime, but it's all as secure as the runtime itself. That's the message I want to give out. If you don't want to read a blog post, and if you want to sit back and listen to the person that runs this, so this is the WASMCon talk done by Nick Fitzgerald, who I believe also works for Fastly, but he's done stuff for Bytecode Alliance, where he talks about all the processes and how it works with security and disclosing stuff. So I'm going to wrap up and conclude, and then we're going to open up for questions. So if you look at, in general, I think Cloud Native loves WebAssembly. Having small workloads that can easily be run and like somewhere in the cloud is good, and I think WebAssembly is a nice fit for that, being that compilation target, right? It has a lot of potential to be like used to run and extend, especially if that component model preview 2 lands. And the tools are there, then we can really do that whole composite thing with locking down stuff, which is nice. As I said, sandboxing and isolating things, especially third-party libraries that you don't trust, will give a lot of value. It's as secure as is runtime implementation. So yeah, if that all fails, of course you need to trust it. But yeah, it will be as secure as that. And Bytecode Alliance is really taking a top-down approach on creating it. And Steve mentioned this morning, it takes a long time to complete a standard. And that's exactly what you see over here. And it will be less of an adaptive one. And preview 2 will be smaller and more bits and pieces, which will allow more quicker progressing of stuff. But I also like the fact that they've shown a basic concept and allow people to work with it. and code access security was just there available, and it was so complex that it was hard to use, right? So that's the opposite side. That's the reason why I love this approach, and I would definitely like to see it moving forward, and hopefully the component model and the tools will fall into place and allow you to do really cool stuff with it that's really secure. So if you look at that repo, that will have the demos later today, right? The slides are in. The slides have a notes version. Those have all the links to the articles that I referred to. You can reach me on my email. I'm on Mastodon, and I'm also blogging, hopefully more frequently, but you can find me there. I'm going to say obrigado. Thank you for attending my talk on Friday afternoon. I hope you can enjoy the last session of the conference, and otherwise safe travels home. And right now would be a moment for questions if there are any. I'm not sure if we have a microphone, or did I just? Oh, you can. I can repeat it. Just yeah.
This model security that WASM provides, it focuses a lot on cloud applications. Is there any movement on the desktop application side that could, because it could leverage the same benefits, I would say?
If you run that WASM time stuff on a machine, as I showed before, then you just have that WASI compliant layer, and you can still do exactly the same on a machine, right? It's the runtime that supports it, and it doesn't matter what the runtime is. And it can be that hypervisor that runs on Project Hyperlight, or it can be that Cloudflare worker that also supports WASI, or it can be on your machine. And if you can capture it inside the component, and I'm not sure if it would land it like how I've seen it, but those demos where they show preview 2, that you can encapsulate stuff and limit the rights of that module, I think that's the powerful stuff. And you can do it on anywhere where a runtime, WASI compliant runtime runs, it's available.
Yeah, obviously, starting stuff from command line or as a service in a cloud, that works fine. That's not how a user on a desktop would typically do it if they start their application.
No, but you can have a single, you have a bunch, like a bundled app that will have the ability to start out WASM time and have a module. There's like in the same way you can take a single executable for .NET, right? You can have that package, that single package, that's just an executable that will start, that will have it all self-contained inside, including a runtime itself.
Okay, got it.
Okay.
No, I have a question.
Okay, cool.
Do you think WASM will allow us to have like providers for database and any other service that we can get access more fast, like than what we have today?
If you have been in a talk, let's say like the one that was done on Orleans today, or you see stuff like Dapper, it's all like about cloud abstractions, and WASI will have, like there are like cloud abstractions already done, which are not like standardized, but if you look at Fermion with Spin, they have certain things where they have like a concept of a queue, which is an abstract queue, and if you then have a WIT file that defines what the queue needs in order to push something on the queue or to get data off of that queue once it's available, that's a definition, and it will just run somewhere. You don't care if it's on Azure, if it's on Amazon, or if it's on GPC or on Google Cloud, it doesn't matter. So yeah, those abstractions are there, but WASI standard itself focuses on, there's like 5 standards that they focus on right now, which I think there's like NN, like ML stuff, sockets, file system, environment, random. Those are the generic concepts which are more like OS-based, and I can see cloud stuff getting into the same shape as well. And then it's just like you define it, and you have the linking done at the runtime. It will have the modules available, and it will match it. As Steve showed this morning, where he took that renderer, which was like written in Go, and then he had the second one that was C#, which just he gave those 2 modules to the runtime, say execute this, and it matched up, right? I can see that happening also for cloud native stuff. That's the power, I guess, right? This is like, because you take WebAssembly outside the browser, these are the demos that we see. But looking at, I think, if you look at Cloudflare, they've got like a WASI-based load, and Fastly as well. There should be something in there. I need to look into that. That's a good question. Okay. Thank you.
Thank you.
Cool. Anything else? No. I'm going to be around till the end of the conference. Thank you. As I said, safe travels back, and hope to see you next time.